hopefully you're already familiar with the reciprocal identities. For example, hopefully you already know that cosine, or sine, is the reciprocal of cosecant, and so I can write that as 1 over cosine, and I know that's the same thing as sine. If you're not familiar with these 6 ratios, or 6 identities, you may want to pause the video and make note of these real quick. We call these the reciprocal identities, and we can use them to simplify some trigonometric expressions. So, for example, down here I have the sine of 48 degrees times the cosecant of 48 degrees, and I want to find an exact value of this, and I don't want to use a calculator. So what I notice is that both of these are the same angle. Now that's going to be key to doing these problems. What we'll do in the next couple examples is take a look at what to do if those are not the same angle. So here's what I have. Let me go ahead and just rewrite sine of 48. I'm not going to touch that one, but what I might do is I might rewrite cosecant. So looking up at the top, I know that cosecant is the same thing as 1 over the sine of the angle. They're an identity, so I can replace cosecant with times 1 over the sine of 48 degrees. And the reason that this is helpful to me is that I see that I'm multiplying by sine of 48 and I'm dividing by sine of 48. So those two pieces will cancel out and leave behind just 1 as my simplified answer. Now, of course, I could have typed this all in my calculator and done it that way, but that's not what I'm looking for. I don't really care that the answer is 1. I care that you can use these identities to rewrite the expression and simplify it. Okay, so that's how these problems are going to work. So let's take a look at a couple more examples. Incidentally enough, these all will work out to be 1. So again, just showing you I don't care so much about the answer as I do the work for these problems. So this time, I notice that I don't have the same angle. One's pi over 4 and one's 5 pi over 4. That's definitely a problem. I need to make those angles the same thing. So the good news is I can do that. We may need to go back and watch a couple of the other videos to do this, but I can remember, hopefully, I have periodic properties that I can use. And a tangent graph repeats, or a tangent function, repeats every 180 degrees or 1 pi. And so what I'm able to do is I can subtract 1 pi from this angle, and I'll be left with something that's equivalent. When I do 5/4 pi minus 1 pi, I end up with just pi over 4. So I see that I can replace that with just pi over 4, and now I have the same angle. Once again, from here, I'll use some of my reciprocal identities up above to rewrite this problem. So for example, cotangent can be written as 1 over the tangent of pi over 4. And then I'll leave tangent alone. I don't want to change that one. And there's other ways that you can do these problems. For example, I could have changed tangent to 1 over cotangent. And again, what I see happen is I've got tangent of pi over 4 times tangent of pi over 4. Those will cancel out, again, leaving behind just 1 as my simplified answer. Okay, let's take a look at one more example. Again, I've got 2 different angles. I've got a 75 degrees and a negative 75 degrees. Well, using some other properties, specifically those even-odd properties, I recall that cosine is an even function, meaning it doesn't really matter if I'm doing, and remember cosine and secant are related, so they're both even functions. It doesn't matter if I have a negative in here. It actually works out to be the same thing as if I had a positive 75. So for a secant or a cosine graph, I can ignore that negative sign, and again, you can go back and watch one of my previous videos to get a reminder of how that works. So again, I'm going to rewrite this second piece, secant, I'm going to rewrite it as 1 over the cosine of 75 degrees, positive 75 degrees. And so once again, I can see that cosine of 75 crosses out, and again, leaving behind just 1 as my simplified answer. So that's how these reciprocal identities work to simplify trigonometric expressions. In our next couple of videos, we'll take a look at some other identities we can use to do some simplifying.